Hey, and welcome back to part 2 of our USMTS Dirt Modified giveaway engine build with Stoen Racing Engines. Last time around, we got the rotating assembly installed in the block, and now it's time to move on to the cylinder heads and valve train. Engine builder Jamie Stoen stabs in the roller camshaft. Jamie worked with Urson on this cam, and together they came up with this. It's a 4/7 swap cam with a grind featuring 260 degrees of duration for the intakes and 268 for the exhausts, both at 50 thousandths tappet lift. The intake center line is set at 106 degrees, and there's 450 thousandths of an inch of lobe lift for the intakes and 430 thousandths for the exhausts. Jamie says he normally installs the camshaft with the timing advanced a degree or two to help the engine really accelerate hard coming out of the turns. But using the cam timing as a tuning tool is certainly one of his options on down the line to help the engine match the driver and the car. So an adjustable timing set is a must here. Because adjusting the cam timing is an option down the road, Jamie uses a billet timing cover from Cloy's with a removable panel that makes getting to the timing chain a snap. It also has an integrated adjustable cam button to set the camshaft in play. Here, he works a little bit of oil into the bearings before installation. And then, once the timing cover is bolted up, setting the camshaft in play is as simple as running the button in or out with an Allen wrench. The rotating assembly is internally balanced, so we'll be using a neutral balance harmonic damper from PBM. This is their SS series of bonded dampers with steel for both the hub and the inertia ring, allowing enough mass to dampen vibrations, but still keeping the damper on a small diameter for quick acceleration. And if you're wondering, no, I don't know where you can get this really cool hydraulic damper install tool Jamie's using. He says a friend fabricated it for him, and he's not making them anymore. I know because I asked if I could get one for myself. Still, pretty cool though. The damper, by the way, is also SFI certified, so it'll be allowed at any racetrack and has laser etched timing marks all the way around, which are pretty large and should be easy to see when trying to set the timing on your race car in a dark pit area. And then the billet timing pointer, which is also from PBM, helps ensure accurate ignition timing readings and won't ever bend on you like those flimsy stamped steel pieces. With the timing cover installed, Jamie can lay down the oil pan gasket. We've already installed the Melling wet sump oil pump and the Kevco pickup. The oil pan is a fully fabricated unit from Kevco with a windage tray and a large kickout to help reduce windage. Jamie recommends Champion Racing Oil in 20W50 weight. Now that may seem a little bit thick to you at first, but Jamie says after lots of testing, he's found the higher weight oil offers better protection even in the harsh environments of racing and in the event the engine runs hot. On the dyno, they'll run it with 9 quarts, but racers will often add an extra quart for a total of 10 just for extra protection from high G-forces uncovering the pickup on the racetrack. But you don't want to overdo it. Jamie says he's run oil level tests and found that with 12 quarts on the dyno, the engine will lose 40 horsepower. For lifters, we're using a set of solid rollers from Comp Cams. They're standard Chevrolet small block diameter at 842 thousandths of an inch, but they're 300 thousandths taller so that the tie bars will clear the tops of the lifter bosses. Jamie has custom, thinner, multi-layer steel head gaskets made from Cometic. With a compressed thickness of 36 thousandths, that's just 4 thousandths of an inch thinner than a standard MLS gasket. But Jamie says he's found it helps tighten up the quench area for better burn of the combustion charge. And now we're finally ready to get to the cylinder heads. The USMTS Racing Series allows a lot of leeway when it comes to the bottom end of the engine. But when it comes to the heads, the only ones allowed are these Brodex spec heads. The rulebook says engine builders aren't allowed to cut, weld, or polish either the ports or the combustion chamber. But you are allowed to deck the heads. So to get as much out of these heads as he can, Jamie has angle milled the decks and managed to cut the 68cc combustion chambers down to around 61 cc's. Still, engine builders are pretty limited here too when it comes to angle milling, because you aren't allowed to change the valve angle more than 1 degree. Although engine builders aren't allowed to touch the combustion chambers, they come from products already CNC cut and they're pretty nice. For this build, Jamie is using steel valves with lightweight titanium retainers, which are all sourced from PBM. The intakes are sized at 2 inches 55 thousandths, while the exhausts are 1 inch 600 thousandths. Now, rules require a minimum valve spring diameter of 5/16 of an inch, but in this case, these are 11/32, just to help move more heat from the exhaust valves and into the head, where it can be carried away by the coolant in the water jackets. Also, notice how high the valves sit in the chambers. These seats aren't sunk into the heads at all. Now, this is a nice touch and helps both increase compression ratio and airflow into and out of the heads. The moment the valves crack open, there is a flow path for air to follow. The way that Brodex makes it easy for USMTS tech officials to check and make sure that the ports haven't been opened up for more flow is by actually casting the word spec in every port, as you can see here. For the intakes, it's in the floor of the port, but in the exhausts, it's in the roof, because those are the areas most affected by any changes. Jamie installs the heads and secures them with a set of ARP head bolts torqued to 70 pounds. While he's doing that, here's a look at the ISKI valve springs and PBM titanium retainers. The springs are set up so that at maximum valve lift, they are approximately 100 thousandths of an inch away from coil bind. That's just to help reduce damaging harmonics. The spring pressures are approximately 290 pounds on the seat and 780 open. That's enough to help this engine live happily at the rules mandated 8,400 RPM redline. Now that's just for the 415 cubic inch motors. The USMTS actually allows a higher 8,700 RPM rev chip for smaller 372 cubic inch race engines, which Jamie also builds. And while I mentioned that this engine will go 1,500 laps between rebuilds, the springs will need to be swapped out for new ones at 750 laps, mainly because the risk of a broken valve spring on the racetrack can result in a very expensive broken valve and grenaded engine. Finally, we're ready to finish off the Valvetrain. Jamie installs and aligns the pushrod guide plates and then drops in the 8-inch long push rods. The rockers are lightweight aluminum units from Urson. We're using 1.6 ratio rockers for the intakes to help get a little more area under the curve, and stock 1.5 ratio rockers for the exhaust. That will make the gross valve lift 1 inch 80 thousandths for the intakes and 968 thousandths for the exhaust. Jamie and his father Roger set the lash on the valves for both the intakes and the exhausts at 14 thousandths of an inch cold. Now that should get them close to the targeted 18 thousandths hot lash setting, and we'll double check that on the dyno once the engine gets warm. And that buttons up the Valvetrain on our 415 cubic inch dirt modified race engine. Next time, Jamie Stoen will be installing the carburetor and intake, front drive, and everything else to get this bad boy ready for a rip on the dyno. So stay tuned.